This is my first talk at React Bangalore and Reactify in general. So thanks for accepting this talk, firstly. I think it's pretty clear what we're going to talk about. React had a new alpha release in June, which is React 18. And this talk is primarily focused on that and like what are the new features, how things have changed, what are the improvements that it offers, and a bunch of different things like that. So a little bit about me. I hope my screen is properly visible to everybody. Cool. So I'm a software engineer at Microsoft. I work on Microsoft 365 and Office 365, which is all the applications that involves, the Office, Word, and everything. So I like to write open source software. I've been doing React for a couple of years, and I like JavaScript and Node, Linux, and I'm also learning Rust, which is my newfound love now. You can reach me at Shriram Balaji across Twitter, GitHub, LinkedIn, most places. I'm at Shriram Balaji. So enough about me. Let's get started. So what are the out-of-the-box improvements? When it comes to React 18, it offers a bunch of different things, but it might be since this is a 30-minute talk, I'll probably try to provide as much condensed information as I can. I'll not talk about a couple of different things, but I'll focus on the main differences between the previous versions and the new version. So we have a new root API, which is a React DOM.create root. There are like a bunch of other concurrent APIs like StartTransition, use deferred value, and a bunch of others. So only a couple of them are documented at this point. So I'll be talking mostly about the StartTransition API and the create root API, which are documented right now. The rest I'll probably not take up in this talk. And you have automatic batching of state updates. So people might be aware of what a state update, what happens when multiple state updates are sort of batched together, and how that behavior is more consistent in React 18. I'll talk about that a little bit, and how and also talk about people who have already are used to concurrent mode. There was a large hype around concurrent mode, and there was a delayed. There's a long delay with suspension concurrent mode, but and how React 18 sort of brings in an opt-in sort of concurrent mode as a concurrent feature of sorts, and also ensures that there's like better smooth upgrade and whatnot. In this talk, I'll not be covering about suspense and SSR and suspense queries because it's like a separate, a large topic altogether, because there has been some significant change in terms of the suspense architecture itself, is what I see from the documentation. Right. So okay, all that is great. Everything looks fancy. Should I upgrade now? Like everybody here is in a React meetup on a Saturday afternoon. I'm sure everybody is enthusiastic enough about React, but you probably shouldn't if you're on a production application upgrade, because it is in an alpha, and like any library that you use, you do not want to upgrade to alpha software unless and until you're sure what you're doing, right? But if you're a library author, you definitely should, because there's like a bunch of things that are changing, and you might need to run some production experiments to sort of help you towards that transition, right? So an official release timeline looks like it's going to take a couple of months at least. So that by the time it matures, if you're not sort of living on the edge, you don't have to worry about it. But if you're someone like me, you can go wild. Right. So now that we're clear what the release timeline is and everything, let's see, how do you upgrade, right? Like, how do you install? I mean, this is pretty obvious that you just do npm install of the React Alpha and the React DOM Alpha. I'll be talking only about React DOM and React for this particular talk, right? So we're used to this particular line of code, right? We are used to seeing this particular line of code where we have a container. In our case, this container is going to be a root element like document.getElement ID of root or something like that, right? So what we're used to, this is the first sort of the thing that renders your app component inside of a particular container. So what changes is, so you have a new root API altogether. So this root API is a create root. They have a function in the React DOM library itself. So that function is where you would pass in your container, which is again your root element that you get by your ID. And then inside that root is where you would render your application. So what's the main difference, right? Why do you have two different APIs? So React 18 ships right now ships with both the legacy API and the new API, just for clarity, right? So they have two APIs. The main reason is what I mentioned earlier, is they wanted a much smoother upgrade process, and introducing such a breaking change in in like a very this is sort of the main thing that every React application has. Like this is very common across React. This is the line that is common across every React application. So in order to sort of smoothen that process, they have both the APIs right now. So what the difference between both of them is when you say the React DOM.create root, you're automatically opting into concurrent mode. There's literally a flag in the React DOM flags that will just gets checked when you're using this particular function. So and if you're using the legacy root API, things still remain the same. You can still use it. But the thing is, it would come with the deprecation notice. If you have upgraded to React, if you have done this particular step and you're still using the legacy root API, in your browser console, you would see a deprecation notice saying that this is going to be removed. So at some point, there would be a breaking change, whereas React DOM.render will not be there, and everybody would have to switch to a React DOM.create root. I think that's the plan eventually. Whether or not it shapes out the way they wanted to is subjective, right? We have to see how it goes. But this enables concurrent mode by default. So this is sort of the opt-in strategy of what I was mentioning, where you React 18 allows you to opt in to having concurrency in the way it renders, right? So that's what this brings to us. So okay, that's the new root API. That's cool and all. I'll talk about concurrency and a little bit about the concurrent mode and how it has changed. What are the concurrent features it offers in the next part of the talk. I'm more I'm very sort of what sort of excites me is things like automatic batching, which is very it's sort of something that you don't think about in your day-to-day writing front-end code, but that's something that makes performance much better. So what is automatic batching? Let's see what is batching first. So you have like a bunch of set state calls. Imagine you have like a bunch of series of set state calls, right? You don't want every set state call to cause a re-render. So you want all of the set state calls. If there are multiple set state calls that are happening, you want them to be batched into a single render. So that happens. It happens in a single render. You don't want to have multiple re-renders. So there's already some automatic batching that is going on today, even in React 17 and before. Right, and even on React 17 and React 18, before React 18, you have some sort of automatic batching, but it's not consistent. And the main thing here in React 18 is you have consistent automatic render batching in multiple different scenarios, even in scenarios that never worked earlier in React 16 and 17. If you also don't want to automatic batch your your state updates, you can use the Flush Sync API, which is I think the recommendation of the React team is that you should not use this Flush Sync API unless and until you're sure what you're doing. So what the Flush Sync API does is takes the entire render tree and then tears it down and then flushes it and creates it sort of renders it again. Basically, you're just forcing a re-render of such. And there's no batching involved when we are doing Flush Sync, right? So that's what it is. That's the thing, right? Like, so, but we want to know, so we do want to know how it works today to sort of understand what makes it different from the React 18. Like I'll provide sort of a pseudo code-ish explanation of how it happens today, and also post the references in the end of where I referred all of these things from. So there's apparently this function called the unstable batched updates function. People who are library authors might already be aware of this. So this is a function that that sort of even in React 16 and 17, if you want to sort of batch your updates, you could use this, and it is marked unstable. That's the reason, hence the name. So if it basically takes all of your state updates and batches them into inside a callback inside the unstable batched updates function. This is and all of this batched updates are run in a single render pass, right? So I'll sort of show the pseudo code of what it looks like, right? So internal handle event is what imagine this is how your this is happening inside of React, right? So we have jumped into React land right now. You guys are all here, so with me right now. So right, so you have an internal handle event, and user provided event handler could be something like an on change or an on click or something like that. It could be anything. It could be an event handler which has like a bunch of state updates or something like that, right? So the batch updates. Imagine a batch update is a queue, an array which is like basically a queue, and every set state update, imagine all of them are going inside this batched updates array, right? So every set state, all set state calls in a given context inside a given function will go inside this batched updates function. And so as you can see in this callback, right? In this callback, this inside this callback, this batched update functions gets populated. It gets populated with all of the set state values. And then finally, you can see that the render with queued state updates thing is called. So basically what this is doing is a callback which has event handler. The event handler has all of your set state functions, and those set states will be pushed into the batched updates array, and all of them will be rendered in a single pass, right? So this is how batching works today. But there are certain cases where this does not work, right? So I'll ask a quick question if someone wants to answer this, right? So this particular piece of code, how many render passes would you think this would take, like before React 18? It would be great if someone sort of, if you could put it in chat or like however that works. I'll wait for a couple of seconds to see if I get any answers. All right, cool. So basically what happens here is the first render, these two are batched, right? So that's the handle button click, which is the user provided handle, right? So that's the user provided handle, and those two set state calls are batched. But what happens, what sort of is weird, or something that people might not be immediately evident, is the second set count inside that is called inside the promise.result.then, that causes a re-render. And there's yet another re-render that gets called inside of the set count. So just reiterating, the first two set state calls are batched, and the set state call, the set count calls that are there inside the promise callback, right? The promise.then callback, they are not batched. Every set state, if you have 10 set state calls, all of them will cause a re-render. That is the behavior that is there today, and this is sort of is non-performant if you think about it in a way, right? So just going back to this piece of code that I show you of how it internally is implemented, so it might sort of start to make sense what it means, right? So in this case, you see this handle button click inside the function itself. It's in the function call stack trace itself. You have both the set count and set button clicked. And that's the reason why you would see that this batched update function will get these two batched updates array will get these two set count and set button clicked set state calls will be pushed into this array. But what will not happen is this, since this dot then happens in a completely different place altogether. So it will basically happen in a separate event loop after the entire this function has finished in a separate callback itself. It is not happening during the event click handler, but happening sometime later, right? So that's the reason why it will not be batched inside. It will not come inside the callback of this particular batched updates, and it will, every one of them will cause us an individual re-render. That's the reason why these two things cause a separate re-render. Hope that is sort of clear. So what changes in React 18 is that now you have consistent behavior, even in scenarios where you have a promise.then. You have a promise, a callback that is available. So even if there is a promise.then, even in that place, you will have automatic batching of set state updates. I'll show a quick sort of demo of this in like a code sandbox, and I think we'll go from there. So yeah, so I'll just show a quick demo of how it is today to sort of yeah, cool. So it just, there's a simple button here, right? So there's a simple button, and I'm here, I'm simulating. So you just take a look at this. This is just a button with just a simple counter, right? And there are two set states, which is like a count and a flag. And based on if this is a, so if the flag is true, you make this as, you change the color of this particular thing. If it is false, you don't, right? So if I click on this handle click, right, you can clearly see that. So this log events function is what is just console.logging render, right? When I click on next, you can see that the set state calls are happening, and there is the click function is clicked once, right? So this is, but you can see that the render happens twice. That's the behavior that I want to show. Why is this happening? Because there's this fetch data dot then, which is basically the same as the promise dot resolve that I showed you, right? Similar to there's a promise and then a set timeout, but you get the idea. It's very similar to that. So you have a promise that gets resolved, and the then callback causes a multiple re-renders. I can sort of show it to you. Again, right? So you can see that every time I click on this button, I'm having two re-renders. So and this is not that's what I was sort of not mentioning, that re-renders inside of a promise dot then callback or a set timeout will not be batched in React 17 and before, but will be batched in React 18. That's the behavior that's the behavior that changes. And this is, imagine, if you can imagine, like this is sort of a very contrived example. People are not writing just counters today, right? So in your production app, if you have like multiple, if you have a promise, so this is similar to where even if you had like accounts data equals await or fetch data, and then you have like a bunch of set state calls after. So if you have like a set count here, even that would sort of this will also not be batched, because please ignore the error on the outside because it's not an async function. But even in that scenario, you would see a very similar behavior where those calls are not batched, right? I think that's pretty clear. So to also demonstrate that this works today without, if it is not inside a promise, here I'm just, there's no fetch data here. There's just two set state calls. And if you, on the right, you can see when I click on click, there's just a single render that's happening because these two state updates are getting batched, right? Cool. Now that that's clear, I'll go on to automatic batching, which is basically showcasing the behavior in React 18. So here on the left side, you can see we are on React 17, and here we are on React 18.alpha, which is on the latest alpha, right? Cool. So this is a very similar, exact same copy of code, but the only difference that you can see here is you're using the new root API that I showed you earlier, where you're using React DOM.create root and then rendering inside it, right? So now I click here, you can see that there's just a single render, right? So even if, so imagine this is this is a huge performance boost if you have like multiple set states that you want to do after a promise. This can be a network call or a set timeout or anything of that sort. It could be anything, but all of those set state updates will get batched in React 18, which is the difference in behavior that we are seeing, right? So that's what I wanted to show here, right? So now that so the automatic batching is great, like having such consistent behavior, sort of remove your it might not be immediately evident for folks who are new to React that having multiple set state calls will cause like a huge re-render or like a bunch of re-renders. So but having consistent behavior right now in like a very common scenario also, I think makes a large difference. So now I'll talk about a little bit about the concurrent features and APIs that we have, right? So, what are the concurrent features and APIs that? So people might be aware of concurrent mode by itself. It came out sometime 16.x. We had a preview of concurrent mode somewhere, I think. But the idea behind that is that concurrent mode will make expensive page transitions less expensive. That's the point, right? If you have like expensive page transitions and animations and whatnot, and if you want to do like a bunch of different things simultaneously, concurrent mode sort of allows you to do it in a way. Simultaneous might not be the right word for it, because I'll sort of explain what actually happens in the concurrent mode. Just a brief of the concurrent mode algorithm itself, but yeah. So it allows your UI to be more responsive in a way, and you can control how you React sort of updates your application when it can update your application. Let's look at the StartTransition API a little bit more sort of in detail, and I'll also cite some examples of this, how the StartTransition API is. So what StartTransition means is that, so if you imagine you have like a bunch of state updates, and if you want to mark some state updates as something that can be deferred for later. So you can mark them as transitions because they are sort of non-urgent, and they are not sort of blocking or affecting the user in any way. So imagine you have like I think an example here is you want some piece of data to be highlighted, but if you also want like a large amount of you want the text input to be fluid, that would be an example which I'll also showcase later. Right. So any update, any set state updates that are wrapped in start transition will be marked as non-urgent, and will be interrupted if there are more discrete events that are coming in your way. So what do I mean by discrete? Is like a click or a key press is a discrete event according to React, because there is why it says it's a discrete event is that a key press, when you say hello, you want to type all of that. So it's a discrete event that has to be marked as urgent because the user is typing. The most important thing right now is the synchronous. You need to take in the user input immediately, and that's what is urgent, and it is not a transition, right? So that's the reason why. Those will be prioritized. If you can sort of move your non-urgent state updates into a start transition callback, right? So a lot of the scenarios today that we use debouncing and throttling, people who might be a lot of you might sort of use debouncing and throttling in your day-to-day use cases. There's like lodash.debounce and throttle and whatnot. It's also probably a very common JavaScript interview question here and there, but in some of these cases would be rendered moot when you start using start transition, and I'll probably explain why that is also, right? So the reason why do we need to use a start transition or a concurrent mode feature is like you have like it's building apps is not it should feel fluid and responsive in a lot of ways. Like a very small action like a clicking a button or typing input, it can cause a lot of things to happen on the screen, and this can cause stuff like the page to freeze or like hang and whatnot, right? But the solution to that is prioritizing what needs to happen when, and then updating anything that is not necessary for later, basically deferring them for non-necessary, anything that is not necessary for later is how you would solve that problem, right? And that's what start transition sort of offers to us. So a very small example of what the StarTransition API is, you can also find this in the React docs or elsewhere as well. So so you have like a typical example is where you have a text input, and then in the text input you set the set state of the text input is marked. It is an urgent thing because every time I type, I need that set state to happen immediately because that's what I'm going to show to the user, right? But the search query itself, the search query which I might be using for maybe search suggestions or anything like that, that set state is not urgent as the input value, right? That's what it means here. It is of course necessary, but the priority here goes to the set input, right? So but if you remember, this is also if people who are used to debouncing and throttling, this is a very sort of a de facto example of right using debouncing. What you would do today is you would wait for something, you would sort of debounce your query, you do debounce your input from sort of triggering or hitting your API endpoint from getting the search suggestions and stuff like that, right? So this is a very common example today. But when you do this with a start transition API, you do not need to debounce it at all. And as the user keeps typing, React will just abandon. So so let's say the user is typing, and he has to type like a long text of like if he, say for example he types Bob, right? And he decides then he does not want, he just goes back and then he types to he starts to type Mark or something like that, right? So what you would do today is you would have a debounce that would wait for a x number of milliseconds, which is like a ballpark estimate that we all arrive at some point, and we debounce that call, so that what happens is we make that API call only after a couple of seconds, right? Couple of milliseconds. But here what happens is so the input would the set state would keep happening for the input, and when he stops it would actually start setting the start transition will wait for for an arbitrary amount of time. That I think it waits for the tick next process dot next tick, if I'm not wrong about that. Someone can correct me if I'm wrong about that, but it waits for the next process dot next tick, and then only your set search query is actually updated. But by the time if the user actually comes back and erases his input and then retypes, you will see that this search query is not even updated. So it's basically React just abandons that work of that search query, and then restarts starts what the original work or the urgent work, which is the setting the input value. So if so why you don't need debounce here is if the rendering was basically fast enough to pause between any of the input events, you're not wasted any time at all. So you're not waiting for an arbitrary number of seconds that you have set that you think might is good for like the user to this is like a gap that the user will have after typing is something that you arrive at, right? So that you do not have to do, and you're not wasting any extra time at all. So you're not taking any more any longer time than what is actually needed for the rendering itself. They will be much clearer in in an example. So let me sort of go to code sandbox, this one. Yeah. Okay. So this is the example that I was talking about, where so this has like 10,000 names. This is like a huge list of names, as you can see, right? And the task here is, as I input data into this particular field, I want to highlight the exact name here, right? So let me sort of show you the behavior if you don't use start transition. What happens today, right? Uh, Let me save this quickly. Okay, so I'll just take. I have not added some scrolling behavior here and whatnot, but you get the point here, right? So I'll just type Laura, yeah, and I'm actually typing here. I'm actually typing like a bunch of things, but you can see that the UI sort of hangs here, right? Because this is a large amount of this is a large list of names, and I'm not using the StartTransition API yet. This is in React. This is still in React 18, but I'm still not using the StartTransition API. So uh, I'm typing Timothy, right? But I decided I don't want to type Timothy. Like, immediately I want to switch to some other name, right? But you can see that it tries to search for that without even I've not debounced this. There's no debouncing that is involved here also. But so what you can see is that this is not fluid. It's not immediately. We are not sure what has to be done here, right? Like, the UI is sort of choking because it needs to also process the input and also render the highlight, and that's taking like a bunch of time, right? So what happens is when I remove the set highlight is what causes this particular the name to be highlighted, right? So if you can see, it's just slicing of the indices based on what text is inputted. I think that's not the point is not how it is implemented, but like the what that start transition API is. But so if I now click on Leora, right, it sort of waits for a second for me to complete, right? So you can see that the user is getting instantaneous feedback that some processing is happening on the side. So yeah, maybe in like a real world scenario, this is again a contrived example, but in a real world scenario, you would not have so many names populated right away. You would probably like populate it from a search suggestions in a separate box of sorts, right? So that's what your real world scenario would be. But even if I want to I'm just typing Jack, and I decide I don't want to type Jack, right? I don't want to type Jack, and I want to type Ol, or I'll say, or I'll type Laura. As and when I type, you can see there's instantaneous feedback, and the input is not choking because we've marked this set highlight as a transition, right? And it is not taking like a bunch of time to sort of render that information because it is non-urgent for us. Here, our urgent input update is our set query, which would be your which is what the input value is, right? So I think that's sort of clear. This is an example. Is an example code sandbox. But there are some other examples that I found in the internet that I think might be interesting to look at also. This is written by Swizek on the Start Transition API itself. So this is like a complex math algorithm that renders like a bunch of squares. You might have seen this as like a rendering performance benchmark of sorts, but it is please don't ask me on the math about it. I have no clue. This looks cool, and it sort of demonstrates Start Transition. That's the reason why I have it here. So. So let's not use start transition right now, right? I will let me just put it. You can see I'm actually moving the slider left and right. Every time I move the slider left and right, it basically renders exponential number of squares, right? That's what it is right now. And this is also CPU intensive. It's not like an easy thing for both the browser to do, right? So, but what seems to happen is the slider here, even though I'm moving it, it chokes because it needs to do a lot of work here, and that's the reason why the slider chokes, right? So now let's see, I've started using the StartTransition API, and you can see that this is very fluid. Like it waits for a couple of seconds. Although it waits for a couple of seconds, it's still the rendering of this is is smooth because it waits. It only does not render the squares unless until it is required, right? And the user input and the user feedback is still very fluid compared to what the previous experience was, where it chokes a lot, right? Just to drive home the point of what the difference is between concurrency and this thing. This is, I think, built by the React team itself. But yeah, so this you might have seen this. I'm not sure if you have, but so the I'll show you the difference between debounce and concurrent, right? So this is again an input, and this data here is populated based on how long. This is junk data, but based on however long the input is, you would see that the things change. So let me type hello, and there's like a debounce that happens, and then after that you can see that there was it changed, right? So again, I type yo, and then it waits for a second, right? But now I switch to concurrent, which uses start transition behind the scenes. I'll try to find the code for it. I was not able to, but if I type the same hello, you can see that is very responsive, sort of very instantaneous feedback, right? Because here we are not waiting or debouncing for an arbitrary number of milliseconds to show the user the output, right? So that's the reason why this is much more fluid and responsive. I think that's sort of explains the start transition API. But right now we've got we've done so much of talk, so much of concurrent. We've said there's so much I think the word concurrent has been told by me like a bunch of times in this particular talk, right? Like there was a lot of hype also, and this often concurrent rendering is what we saw. But the main for people who have followed React is the thing is that there's no concurrent mode. Sorry to spoil your the hopes of concurrent mode, but there's no concurrent mode. But it's just a bunch of concurrent features that you opt in into React 18. So that's how concurrency is would be in React going forward. I think they've had multiple iterations of this, and then they've arrived at this as a way to sort of make people more sort of accustomed to how concurrent UI is and will be, right? I'll just take a small peek at how. So our models of writing code or writing UI applications are sort of in event-based manner, right? Like it's very linear in a way, right? That there is the user has an input, there is an on-click event, something happens, it triggers an action, there is a callback that happens at some point, and then you have. So this is very linear. So it's just a linear sequence of actions of sorts. It might be asynchronous, but it's still linear, right? But the mental model that we have is slightly has to adapt to this concurrent way, right? But even though they say concurrent, the way they've implemented this is they use this thing called as the it's people might be aware of this in your operating system slash if you have done CAS. It's they call this non-preemptive multitasking, right? So that's or non-preemptive scheduling. This has been there in React Fiber also. If people have in React Fiber also, there was this cooperative multitasking algorithm, but they have tweaked it for concurrent mode in this sense that there is more granularity today with concurrent mode in this algorithm. If for me it was a little bit difficult for me to wrap my head around the sort of the nuances of that because I've not sort of looked at how the code is implemented or stuff like that. This is sort of based on explanation that I've seen on GitHub discussions and I've read across multiple places, but I'm still sort of trying to wrap my head around that as well. But the gist of this explanation is that you have like a single rendering thread. So you have a single rendering thread that allows for other events like other main thread tasks. When I say main thread tasks, it could be a user typing, it could be network events, it could be an animation, the browser relayout paint, and everything, right? That all of that happens on the main thread, but there is a singular rendering thread. So you imagine like you have like a long thread that you can sort of chop and do other stuff and then continue eating that thread. So imagine if you have like a big one huge noodle and you just sort of chop it into different pieces. One of those pieces you just put in some sauce and then the rest of them you just keep consuming. That's sort of a way that you can look at this particular diagram. I can think of a noodle and a spaghetti to me. Maybe it's 3 p.m. and I'm hungry, but that's another thing altogether. But so you have this render task, and there is a user input, and you stop at that point. Your high priority task here is to do that synchronous update. Here, your rendering synchronous update could be where you type the user types, and you have to show that data in that particular input, right? Which is again the high priority task, and then you resume or your original render task, right? But unlike an operating system scheduler, we cannot just say, let's just stop this render, just throw this away. That's not how the cooperative multitasking algorithm is. That's the reason why it is cooperative, right? So it is cooperative in the sense that it yields control between React components with and there is a heuristic to it. So when I say it yields control, it might sound similar to people who have studied like operating systems and whatnot. But basically, yielding control is just switching context of sort. Basically, taking control from one component and giving it to the other of sorts, right? Taking control from one component, giving to something that is much more, and then coming back to the main thread after like a period of time. So to think of this as just passing away control to one component to the other. That's how this cooperative multitasking algorithm works. So they sort of yield to the main thread every 5 milliseconds, because they say that it's smaller than like a single frame, which is like that's the heuristic that the React team has chosen. The details of that, or why they've chosen that, is beyond me. I still need to do much more research to sort of understand this in a better way. But that's how this seems to work. You have like a single rendering thread, and it sort of switches. Imagine this is like switching to something that is more important than coming back, right? Say for example, you've been working and then so you've been working all day, right? As engineers, we've been working all day, and there is an important event that happens is that you have to eat and it's sometime past 12 p.m. Or 12 a.m. actually, sometime past 12 a.m. And the important event is that your body generates this urgent event, which is called as the hunger, right? And you respond to that, but you come back to your original render task, which is actually writing code. So that's how I've thought of this as you're also cooperating, because you're also cooperating with you yourself and your mother also, right? So that's how I think of this as the cooperative multitasking algorithm, right? In a way. So taking all of that, but the main takeaway for me or anybody who's watching this talk is that the future of concurrent React is very exciting. You have a lot of things that are coming that will make by default out of the box your app might be faster in things that it's doing. There are things that are bound to break, and I'm sure that the React team sort of will address them. Because a lot of things are still in alpha, you can still provide feedback and whatnot. I'll provide references to. I've provided references to all of this. I suggest that anybody who's watching this talk to go and look at the React working group. So React has like a very community focused thing right now, where a lot of discussions are happening on the React working group itself, and like they have like a lot of different discussions. Even though you're not interested in React 18, there's like a bunch of important things that are sort of mentioned even in the comments. Like if something is sort of not you're not able to wrap your head around, I'm sure someone has like a better explanation from the React team itself. Specifically the Elify or Explain Like I'm Fi and the glossary, I found it really useful to sort of wrap my head around different concepts. And if you like interesting analogies and stuff like that, you can find them there. A mostly complete guide to rendering. This is something that is written by someone from the Redux team itself, if I'm not wrong. And so that also gives that is where I found the references to the unstable batch updates and whatnot. You can also find this slide deck is also open source, and the repository for that also I've attached it here. And all the inner workings and everything that I've talked about, all of them are in GitHub discussions in the React working group.